areas in between. And wherever riparian zones occur, they're the focal centers of plant and animal life in the area. Finding riparian areas is not always easy in the arid Southwest, but once you come across one, there's no mistaking it for anything else. The first thing you'll notice is a dramatic shift from whatever characterizes the particular region to more of everything, with a wide variety of new plant forms gracing the landscape with their presence. The change may be from almost nothing to something, from sparse to lush, or from conifers to deciduous hardwoods. Among the large trees that characterize riparian areas, cottonwoods are by far most widespread. Throughout most of the state, there will be an understory of willows, and depending on elevation, may be joined by sycamores, box elders, Arizona walnuts, ashes, and a variety of other towering trees, all shading the areas and cooling the waters. Many of these trees, while common along watercourses, can grow naturally nowhere else. As you move into one of these areas, you'll quickly notice much more than trees. Grasses are usually abundant along the banks, and there's a far greater variety of shrubs in flowering forms. You'll also notice a dramatic change in the wildlife. Birds will be flitting among the trees and bushes, and if you check the soft soil near the water, you'll probably find the tracks of raccoons, rabbits, and other small mammals that have visited or perhaps live full-time in the area. If the water is permanent or perhaps available most of the time, you're likely to find frogs, toads, salamanders, giant water bugs, and a host of other creatures that cannot exist without such havens to call home. And while riparian areas provide permanent residence to all the animals that cannot live elsewhere, they also lure in many others that range over much wider areas. Deer, javelinas, and elk visit the stream sides, and there they find food, shelter, and water. Black bears use them as personal highways. Food there is diverse and plentiful, and the traveling is cool and relatively easy. Birds are everywhere. Nearly half of the 116 species known to nest in Arizona choose cottonwood and willow habitats to rear their families. Here, the plant associations provide the tall trees needed by some species, including the great birds of prey that like to roost and nest high off the ground, and abundant shrubs for those that need this kind of habitat. Here there are grasses and weeds teeming with insects for warblers and flycatchers, and abundant seeds for the finches and grosbeaks. So what is the role of Arizona's riparian areas? You might think of them as magnets for just about everything that lives in Arizona, and the only suitable habitats for many plants and animals that can't survive without them. They attract elk and hummingbirds, towering trees and dainty flowers. And perhaps most important of all, they attract man. Most evidence of prehistoric humans is intertwined with riparian associations. Even the cliff dwellings, perched like swallows' nests on the side walls of steep cliffs, overlook reliable water sources. Early explorers wound their way into Arizona along the water courses, following them like migrating birds, secure in the knowledge that if they stayed near the water's edge, they could always find their way back and have the very best chance of finding their means of sustenance along the way. If you follow the dim old trails of Coronado, Padre Kino, and the Mountain Men, you'll be moseying along one or more of Arizona's riparian areas. And that's really the beginning of the problem we face today. Early settlers chose streamside locations for their farms and homes. Travel was easier along the streams, so roads developed nearby, often clinging tightly to the stream sides. Miners needed water to work their claims and process their ores, and they still do. Cattlemen and sheepmen pastured their stock along the waterways first, and in time, communities developed, all in near association with water. While these early activities had their effects on riparian areas, it was the construction of dams on the major rivers that had the most profound effects. Roosevelt was the first. Then it was soon followed by 3 more on the Salt River, 2 on the Verde, 1 on the Agua Fria, and finally, Hoover and the others on the Colorado. No longer could floods dump fertile deposits of soil onto the floodplains almost annually. Without this replenishment, soil nutrients declined and alkaline deposits accumulated. The soil was no longer as able to produce as it once had, and fertilizers became a standard part of farming. The character of the riversides changed. Once, nearly 10% of Arizona was riparian in one way or another. Broad floodplains produced widespread stands of giant mesquites where wildlife found food and shelter. Now these mesquite bosques are scarce and getting scarcer. The stream sides lost their stands of tall trees and their lush green undergrowth once the waters stopped flowing regularly. Now the drainages show arid zone plants and hardy forbs able to suck what moisture remains from the stream beds. Today, the 10% of Arizona that was once riparian area is down to 1% or less, and the loss is still going on. Mankind is doing just fine under the present-day arrangement. With all the major rivers dammed and controlled to serve his needs, he can continue to live here and enjoy what's left of Arizona's prime habitats. For now, anyway. But what about tomorrow? With 90% or more of the areas that cool the surface and replenish the groundwaters gone, how long can today's pace continue? Take away the lifeblood of an ecosystem, and in time, the ecosystem is also destroyed. Man has the advantage of his inventive intellect to prolong his survival, even with the very essence of it corralled, tamed, and stripped to a minimum. But what about the wildlife? The plant life. The very things that made man want to live here in the first place. So where does all this leave us? Today, now. There are things being done to help and other things that can be done. Some rejuvenation is probably possible, but not always feasible. Harmful practices, though, can be modified or altered. New roads can be moved back from the riparian areas instead of following them religiously. Logging operations can leave buffer zones along the streams and near the lakes. Livestock can be fenced to get their water only at selected spots, rather than being allowed to browse off all the new growth along the streams, including the tender young cottonwoods, and trampling the streamside soil into compact hardpan while they're at it. Grazing can also be rotated so the areas can rest between periods of use. Mining companies are now aware of the riparian damage they can do and can be encouraged to hold additional destruction to a minimum. Many areas can be restored once the immediate need is met, and often the main part of an operation can be moved away from the prime riparian areas. There is more that man can do. Wastewater can be utilized to provide certain kinds of prime wildlife habitat. Careful planning can actually enhance waterside zones instead of destroying them. Small retention dams can improve trout streams, and the use of motorized vehicles can be minimized along the banks. These attitudes and many others are not really options. They're musts if Arizona as we know it is to survive beyond our lifetimes, perhaps merely through our lifetimes. With 9/10 of our ecological lifelines already gone, we cannot afford to lose more.
Since the beginning of time, thousands of plant and animal species have become extinct through the natural change in physical and biological conditions on our planet. During the 3,000-year Pleistocene Ice Age, North America lost approximately 50 mammal and 40 bird species. At a time when extreme climatic change altered virtually every habitat and life form on Earth, extinction was clearly part of the natural order. In just the last few centuries, more than 500 species and subspecies have become extinct. No longer can we solely attribute the loss or decline of these species to natural processes. Today, man's alteration and elimination of habitats is most responsible for this alarming increase in extinct and endangered species in our ecosystem. In 1653, Isaac Walton wrote The Complete Angler, an Englishman's discourse of rivers, fish ponds, fish, and fishing.
And you are to note that there are several kinds of trouts, but these several kinds are not considered but by very few men, for they go under the general name of trouts, and it is so with many kinds of fish and of trouts especially, which differ in their bigness and shape and spots and color.
Since Walton's publication, hundreds of species of fish have disappeared from our waters, and hundreds more are now classified as endangered. Recent extinctions have resulted from severe changes in aquatic habitats, changes that happen too quickly for native organisms to adapt.
Man created them too fast. Things happen too fast in the last 100 years. So a fish can take something and change to adjust to that change if it takes 1,000,000 years for the change. And when you change things abruptly, and in 100 years stop a river flowing or change the temperature of that river in a matter of minutes or hours, fish can't adjust, so they become extinct or endangered.
The first explorers who came to the Southwest found a much different land than what is found today. They found vast grasslands filled with buffalo and antelope, and forests filled with deer and elk. The rivers and streams they found were also much different. There were no dams or reservoirs. the grasslands and forests acted like great sponges, absorbing the rainfall and melting snow, letting the water run slowly off the land. The last 2 centuries have changed all that. Early settlers established communities along rivers and streams. Water was diverted to grow crops, and eventually dams were built to generate electricity. The introduction of cattle and overgrazing resulted in soil erosion, all of which have had a major impact on aquatic habitats.
In addition to direct modifications such as dams, channelization, water diversions, and so on, is that about 100 years ago, there was a cycle began of arroyo cutting, or cutting of gullies. And the things that all of us are familiar with now, the deep cut gullies in the, along the highway and so on, were eroded in a very short period of time. In approximately a 20-year period, many, many streams that formerly flowed in wide valleys cut deeply into their stream beds. What it means when you incise a floodplain, you have a floodplain that is not only a flat land surface, but beneath that land surface there's water, a water table. And that water table is about the level of the river that flows through the floodplain. So if you cut the river down 20 or 30 or 40 or 50 feet, the water table drops too. Okay. So now what that means is that you've lost the reservoir, you've lost the buffer, because in periods of drought, there's no water table to slowly leak into the river to keep the river flowing. And once you cut to bedrock, then what you have is a sluiceway where water moves from the head of the watershed through the sluiceway with no storage through that system. Pumpage does the same thing in a different way. You pump it out and it does the same thing. So you've lost your buffer against drought. And once that's lost, the system is unstable.
All of these changes have severely altered the physical and biological conditions beneath the water's surface. Another intrusion was the introduction of non-native organisms, fish that were transplanted from other parts of the world.
One of the biggest culprits as far as the demise of native fish species in the Southwest has been the introduction of fish that are not native to these waters. A splendid example of this is the big predatory type fish, say northern pike or largemouth bass. Many of the native minnows didn't have any big predators that chased them and ate them. So the end result was that when we brought these predators in, they just didn't know enough to avoid them. They never had to avoid these type of predators. And so these particular fish have really dominated these streams, rivers, and lakes. Another one that isn't as conspicuous is the red shiner. We don't know how the interaction occurs, but it seems as though when the red shiner comes in, the native minnow species, a small, what we call the Natropus, or the shiners, the native shiners, disappear. Somehow or another, red shiners are able to replace them. It may be competition at a very low level. In other words, amongst larval fishes, maybe red shiners eat the larval native shiners. But for some reason, as red shiners have spread throughout the Southwest, there's been a decline in the native shiner species.
Native trout have faced a similar situation. 40 to 50 years ago, non-native trout were stocked throughout the Southwest, rainbow trout from the Pacific Northwest, and the brown trout, originally from Europe.
Well, the end result was these fish outcompeted the native trout. Either outcompeted them or they bred with them and hybridized with them. This is what happened with the Gila trout in the Gila wilderness. Rainbow trout were put in these streams. They bred with the native Gila trout, and the end product was not a Gila trout, it was a hybrid. And eventually, if it would have continued, there'd be very few Gila trout left. The brown trout is another example of a trout species that was brought in It has an advantage over the native trout in that it's a fall spawner. So that when the young come off in the fall of the year, if they survive through the winter and into the spring when the rainbows spawn and the young fry, the small, sack, what we call sack fry or fingerlings come up out, out of the gravel, they're preyed upon by the browns. And the browns are also very, much more aggressive than some of the native trouts. The native cutthroat trout, the Rio Grande cutthroat trout, is another example. In some of the high mountain streams, brook trout have replaced them because they are better adapted to living in these conditions, and they can actually force the native fish out. They can take over the habitats that they occupy. So the end result is that a lot of these streams which formerly had native fish no longer do. They have the exotics.
The expansion of human settlements and accelerated development of natural resources continue to threaten the existence of many species of fish. Some examples of endangered southwestern fauna include the Colorado squawfish. The first settlers called it the white salmon of the Colorado. It is the largest of the minnow family, reaching a length of 6 feet and weighing over 100 pounds. Once this fish was so common that it was caught commercially by the wagon load. The razorback sucker is another example of the large river fish species in the Colorado Basin. These fish were commercially harvested in Arizona until 1949. They reach lengths of up to 3 feet and weigh as much as 14 pounds. The humpback chub, also a native of the Colorado River, evolved its unique shape for better stability in the rough current. The squawfish, razorback sucker, and humpback chub are 3 of the 4 endangered large river fishes of the Colorado Basin. Of these big native Colorado fishes, the bony-tailed chub has come closest to extinction. Like the razorback sucker and Colorado squawfish, bony-tail are long-lived. Recent age determinations of 2 Lake Mojave specimens place their age at 40 years. Since 1935, more than 20 dams have been constructed within the Colorado River Basin, resulting in drastic habitat changes. The dams blocked migration to natural spawning areas, thus reducing stock to dangerously low levels. Another endangered fish is the Gila top minnow. Once, this small guppy-like fish was the most abundant fish in the Gila River of central Arizona and southwestern New Mexico. The top minnow's disappearance resulted from the deterioration of its aquatic habitat and the introduction of the non-native mosquito fish. The mosquito fish competed with the top minnows for food and also ate the top minnow's offspring. These are just a few of the many endangered and threatened fishes of the Southwest. Well over half of the native southwestern fish fauna are now facing the real and imminent threat of extinction.
I think one of the principal reasons that it's important to deal with fishes as well as some of the larger endangered species is that any part of the biological system that we deal with, such as in water, depends